Hello and welcome back to the Developer's Guide to Windows 10 Insider Preview. I'm Andy Wigley. I'm with Jerry here. We're going to do a session now. We did one on local file storage, but a lot of developers like to work with local databases.
There's something about relational data that just makes it easy to work with.
It really is, and some of the things you want to do with storing it in files, just kind of difficult when you've got relationships between one collection of data and another. So it makes a lot of sense.
Developers have a lot of access or a lot of experience, of course, with SQL Server, but developers who work on all the platforms out there have one thing in common. They're able to use SQLite, which is, of course, is ported to just everything, including Windows.
Yeah, so for a lot of developers, like you're saying, bringing their apps to our platform, used to working with SQLite, and we're pleased to say that we have great support for SQLite in UWP apps as well. So we're going to look at why you want to use a database. Mm-hmm. Let's just kind of get that one out of the way. Well, we kind of already did. We just said that. If you've got relationships between one set of data and another.
Relationships are hard, Andy. It's not your fault.
I know. But this SQLite can help you with that. And why SQLite in particular? There are others around. There's a good number of others in-memory databases and fast embedded things.
It's just such a popular one.
It's so popular, yeah. And then looking at how we access this from actually from .NET using C# or VB. So there's kind of things you need to know about that. Then we're just going to run through a quick example of the basic CRUD operations: create, read, update, and delete. That means looking at how you might, with just one of these wrappers, these .NET APIs. There are various different ways of doing this, so we haven't got time to go through them all, but we're going to pick on one of them. Then a little bit about some of the cool stuff you can do with databases, about building into the database itself some kind of data health features, like actually making sure you do updates within a transaction so that it either all works or it unfolds, and relationships, so the things like you can kind of put into the database constraints that mean that the health of your data is maintained by the database engine itself. So things like if you insert a record into this table, the value in that column has to match to the key value of an item in another table. So making sure that your data is healthy.
So SQLite in particular is a very rich application, and so you have a lot of features. But to be clear, this is not SQL Server. It doesn't have every feature, and it never could, right? SQL Server is absolutely amazing.
Yeah.
This is really meant to be inside a small application that ships onto a mobile device. But when we look at all the features and the capabilities, you're going to see some missing features, not critical ones, but one of the reasons is this is a very high-performance database, and it is very small and lean, and so it's able to do quite a bit of things without much overhead or demand on the device itself.
That's right. So we're not talking about somehow weirdly installing a database server onto a phone or an IoT device. This is an in-proc database engine, sort of a in-proc relational database.
So let's talk about where we'd find it.
We find it at SQLite.org. So this is it's the world's most widely used small database. The
world's most widely used small database.
Yes.
Very good. Okay. Then we don't have to compare it with SQL Server.
No, that's right. So SQLite.org are the body that maintains it. It's supported by a lot of industry bodies and companies, but they are independent and they do SQLite database engines for all the major platforms and a lot others beside as well. So
this is an open source project.
It's an open source product.
Microsoft is a big contributor to this open source project.
That's right.
Yeah.
So on here you will find SQLite for C++ and for iOS, for Android, and for our platforms, and lots of documentation and good features and descriptions about what the product is and how it works. Now for our use, talking from the perspective of a C# or VB developer, the thing that you get from SQLite.org is a native DLL, SQLite 3.dll, and that encapsulates the database engine and all its functionality, and it exposes a callable API layer, a C API, that you can, if you're working in C++, you can just call that directly. If you're working in C# or VB, we need to have a wrapper around it that allows your code, your C# or VB code, to make use of it. And there are a number of them. Just to pick out two here, SQLite.net is actually probably probably the most popular.
It's the only one I've really played with myself, to be honest. Yeah, very popular.
It is very popular, and that gives you a link to SQL kind of syntax for going at it. So we're using link statements. So you're saying from in db.table customer, you're selecting from the customer table where whatever, select. So it's classical link syntax in order to select items.
Great, because if you type something wrong, you get compile time errors.
Yeah.
Very nice.
So that really is, it's probably the one I prefer as well. But if you're more used to working with SQL statements, there are a number of wrappers that allow you to work in that way as well. So a lot of people are used to writing.
And it doesn't automatically hydrate classes or anything like that. You do it yourself. That's the SQLite PCL is really for developers who are probably paid by the hour.
Yes.
There's a lot more work involved.
Yes, that's right. Yeah, so SQLite.net, as Jerry is alluding to, has a lightweight ORM in it, an object relational mapper. So it does the magic of taking objects out of the SQL database, which is a table structured storage system, and turning them into C# objects.
Yeah.
And it does that for you automatically. It's wonderful.
Strongly typed, easy to work with, bindable. Everything.
But SQLite PCL, if we can just have a look at that, you can see that you're working with an English language command, select ID name from customer where ID equals some variable name. So this is...
if you had a typo in that, you wouldn't know until you ran it.
No, that's right, exactly. So what happens is that statement gets sent off to the statement parser part of the database, which kind of figures out from that sentence what exactly you were asking for.
Yeah.
And then it goes off and pulls the records back, and then you have this. You have to actually build your C# objects yourself. So the bottom bit down there is saying if SQLite result.done is equal to statement.step. Well, this is the SQLite C API exposing itself. Then you can create yourself a new customer object by reading the values out of the statement collection that gets returned to it. It's pretty, well, if
that's like running a race with boots on, man. That is a bad deal.
Yeah, but this is, this is the way a lot of people like to work. So we offer everything. So I'm with Jerry. I think SQLite.net is beautiful and nice way to work. But
all right, so getting SQLite out of the theory here into Visual Studio, we want to start working with it.
Going to move me on there. So to install the SQLite database engine, to make it available to your apps, first of all, you need to go and get the Visual Studio extension for SQLite, which in the goodness,
V6.
The V6.
Visual Studio, what's the I? Interface extension. That's what it is.
Yeah. So in the goodness of time, that will probably be available from, you go into the extension updates wizard, which you can get from the whatever it is menu in Visual Studio. And tools, the tools, extensions, and updates. And in the fullness of time, that will be available through the online tab of that editor. It's not currently, at the time that we're recording this, just a couple of weeks after build. At the moment, you need to go to SQLite.org to their downloads page, and they've got a beta of the V6 for SQLite, which you can install and use today with your UWP apps.
If everybody just got confused, you meant beta.
I mean a beta. Yes. All right.
That's how cowboys say it.
So that's the database engine. So then you need to add a reference to it, and you'll end up in your references list SQLite for Universal App Platform. But all that does actually is adds the SQLite3.dll into your package. So in addition to that, you'll need to add from NuGet one of these C# wrappers. So,
which is what we talked about at the first slide.
Yeah, that's
okay,
right.
so
two parts
you're installing two things, the
things.
extension, and then you pick between SQLite.net or -net and SQLite PCL.
Yeah, so I'm choosing SQLite PCL just because I had to pick one. Yeah, I know. I actually have two versions of this deck. I have numerous versions of this deck for over the years. One of which is SQLite.net, and this is SQLite PCL.
Lovely.
Whatever. And actually, if you look at that picture there, SQLite PCL, directly underneath it is SQLite.net-PCL, which is one of the flavors of SQLite.net you can get from NuGet. So it's all there, folks. Choose the one that you want to work with. Okay, let's just run through the basic operations. If you want to store, and this is the SQLite PCL method, so I'm afraid you're going to have to grit your teeth, Jerry.
No, I mean, are we going to make it in time? Just kidding.
So yeah, SQLite PCL, really you're quite close to the SQLite C API.
So this is the advantage of
If you want to work, if you're used to working with it at this level, this is the one for you. There's another one that I support, SQLite WinRT, which hopefully will be back on NuGet by the end of the month, which a few of you out there are using, I'm sure. Well, I know you are because I hear from you.
both of them.
Both of them. But you interact with the database using, in this case, SQLite PCL with SQL statements rather than with link statements. So this is how you might create a table. Look at that, all that beautiful red text.
Boy, it's lovely. I love literal strings in my app.
Yes. This is the way.
I'm going to stop giving you a hard time. I'm sorry.
This is the way Jerry loves to do it, and and we do understand that people out there love to work like this way. So here we are. Create a table.
No, people like very efficient code, and this is efficient.
It is efficient. Yeah. So what you do is you make your statement. You new up a SQL. You first of all create a SQLite connection. That will create the empty database if there isn't one there already. You create your tables. You prepare the statement. That's a step. And then that's the step. That's a step in executing it. And then you step the statement. This is the C API.
Obvious.
Yeah, it is. Step. Who thought of that? Then, if you want to insert some records, you can use a SQL statement like this. Insert into customer name, city, contact. And then you need to plug in the values that are going to get substituted into that statement. And just to add to your pain, Jerry, it's a one-based collection there. How about that?
Instead of a zero-based?
It's beautiful. It's a one-based collection. It's a long time since I've seen that.
So neat.
It's
lovely.
lovely.
Seriously,
it's fun. This is just fun. If you want a challenge, you want to, this is it. Select. You can select, obviously, from tables. Select ID, name, city, contact from customer, where ID equals some variable value. You then bind in that variable value that you want to actually select on. You step the statement, execute it.
Yeah.
And if that comes back as done, that means it's returned to you a collection of objects, which you then have to cast to the relevant type. So long string, string, string in this case. So we're now newing up a customer object. So this is our own lightweight ORM wrapper for this.
Got it. So the customer object now gives us a fully strongly typed customer.
That's right. And now you've made some changes to that object and your user has used your UI and you now need to store it back in the database and you use an update statement, update customer set. Name equals loads of question marks in there, variables again. Again, you bind the values into the parameters in. One based again, wonderful.
Yeah, that's neat.
And then you step the statement at the end to execute it.
Nice.
And the easiest one, the last one of the lot, delete. So this one, you again prepare your statement, bind in the variable value, the parameter, and then step it to execute.
Well, I'll be honest, it actually doesn't look all that complicated. Let's step into a demo, man.
Step into a demo.
Getting used to the step business.
Right.
That's nice.
Okay, Visual Studio. So I've got I just got rid of that because I was checking this out because I hate that things. Right, so this is a very simple little demo. Just to show you. Here we've got a customers table, and it has some child values. So this is where the value of a database. So I can click on the AdventureWorks customer, and it shows me the 3 projects, which are child objects. I've got 2 tables in here, a customers table and a projects table, and there's a relationship between the items that's in the projects table, which contains all the projects, and this is a classical parent-child relationship.
Sure. Sometimes master details might be referred to.
Master detail, yeah. So that one doesn't have any projects. This guy, Fabricam, has 1 project, soccer scheduling, and this one down here has, has 3.
Is there a visual designer for SQLite?
I'm going to come to that. Come to that. But let's just walk through a little bit so you can see the flow and a good way of working with SQLite. So I'm going to enable my breakpoints and just step through this. So first of all, when we launch the app, you're going to execute a method like this, load database. So the very first time the user changes, sales meeting, how about that? That's weird. I turned off notifications on my system, but it's clearly not working.
It is marked as off. That's hilarious.
Yeah, it's broken actually on my system, my build. There you go. The truth is out. So here we are, create table, If not exists, customer ID. I don't have a sales meeting. What is that?
I don't know. I was thinking of like, what could that possibly be?
I don't do sales. I'm evangelism. What is that? Oh my gosh, my job has changed. Nobody's told me.
Secret is out.
Huh.
All right, so this is how you create a table. It's a syntax that looks very familiar to the way you create a table in SQL Server.
That's right. So you prepare and statement step it. But we've got two tables. Create table. Then we're creating our other. This is the
the
detail,
child.
the project one, child. But you'll notice it's got a customer ID column in it here. This guy.
Oh, the foreign
which
key.
Which is the foreign key, which is the ID value from the parent goes in here, and we've got a foreign key constraint declared down there in order to make sure that relationship is maintained and you can't put any bad data into this thing. So we prepare that and execute it. Here's a slightly weird thing with SQLite. Actually, having declared a foreign key constraint up here, SQLite promptly ignores it. Unless you turn on this, you execute this pragma, foreign keys equals on. So now it will actually constrain, it will actually use that foreign key constraint. So that's just another statement that you execute. Okay. So there we go. That's the prep thing. Now we're into our page where we're going to show the customers. I'm just going to step through this one. We're going to go into our view model and get all the items. So I'm going to step into that. And here we are. This is my, it's kind of like my SQLite repository, if you like. You can tell this is old code as well. At the top there, we've got hash of Silverlight. All this works with Silverlight as well, folks. We're going to create, now this is interesting, this is a table view model base, which is the way I build these applications. And what this is an abstract base class. It's an abstract class that it's intended to be inherited from. And it's a generic table base class for any table that's in SQLite. And it takes the item type and the type of the key. So this is my customers table. And in it, it's got all of the standard SQL statements. So you can select all, and each of these has a select, has a get the SQL for the execute for the method, and then fill it, which means plug in the variable, the parameter values. So we've got create an item which doesn't have any, get select item, fill select item, get delete item, fill delete item. So this is the base class. Now the important thing comes. You then inherit from it in a child class, which inherits from that generic base class. So here we go. Our customer's view model is a SQLite table view model base for customer objects, which is our model, which has a key of type long. And then you simply plug into this. This is one class where all your SQL statements go, so you don't have them littering your project and being really untidy. So here's the SQL statement for getting all of the customers. This is where you get a specific customer, and this is where you plug in the variable that matches to that. So it's a real nice way of keeping it really nice and neat and tidy. This is the SQL for inserting in. This is where you fill in the variable values. So you change your table, you just have to edit this class. You can see how it works.
Yeah.
Where were we? In here. Okay, we were preparing our get select all SQL statement. So, and then we fill it, so this is where we plug into the statement the value, so we're calling into that child class. Then we execute it, and we're going to keep looping around this. We're adding it to our output collection, and this is where we are pulling out all of the items from the database, and this is our ORM, if you like.
Yeah.
Okay, did you get that? It's kind of this solution will be up on GitHub, so you can study how it works. But it's a repeatable pattern for working with SQLite in this kind of style.
And when you think about implementing a database inside an application, having simple data is one thing, but having related data with a foreign key between them, that's a pretty common scenario. So it's a very handy app to just get people started as well.
Yeah, that's
but
right.
when it comes to things like relationships, when it comes to things like transactions, when it comes to the constraints of foreign keys, there's probably a little bit more to it than the demo that you showed us. Maybe you could walk us through some of the issues that developers get to think about?
Absolutely. And this is kind of, at the moment you might be looking at a simple example like that and thinking, I can't see why I'd bother.
Yeah.
It's rather antiquated. Statements, SQL statements. I've worked with both. I like both. But,
I do too.
Or you could use the SQLite.net, and use a links syntax. But why
nice
bother?
The nice thing about a literal SQL statement, I will say this, is you get to tune it.
Yep.
You know what I mean?
Yep.
And get it just the way you want it to be.
Yeah, and it's nice. And if you like working,
I can get on board.
If you like with SQL Server, you're going to kind of like this thing.
That's right.
Yes. So, but but for simple scenarios, you're only going to want to use a file system. So the real power of a relational database comes from the other stuff you can do, the transactions, relations, and other constraints. So transactions first. So this is the idea where you want to make a collection of changes to your database, but you want to make sure that they either all happen, or if something goes wrong halfway through, you don't end up with a corrupted database and it then would roll back any of the other changes. And this is a feature that databases just have.
This is fundamental to a
database.
So you have to have transactions, or you don't have integrity.
Indeed, yeah. So in actual fact, and this is true with SQL Server as well, if you don't explicitly declare a transaction around a statement, it kind of implicitly creates one. So
you get one for free.
You get one for free. So even just a simple SQL statement.step command that we were doing there, that actually internally is being wrapped in a little begin transaction, end transaction around it.
That's right.
So, but the real thing for you is if you want to do a bunch of changes to the database and then make sure that they all get committed or none of the changes happen. So then you just execute around your code a begin transaction. So at the top there, we're preparing a SQL statement begin transaction. We step it to execute, and then we do a bunch of changes. So we're in here. In this example, we're inserting a customer, and we're also inserting a project. And you might have one too many of these kind of statements. And then when you're ready to say, okay, we're done, I want to now commit that new view of the database and commit it to the database and make sure that it's solid, then you would call commit transaction. And the database engine guarantees that all those changes will then be applied.
It's nice because this syntax, begin and commit transaction, that's just standard T-SQL that, SQL Server uses it, but most databases use that syntax, so it should be familiar to most developers who know about databases.
Absolutely.
So creating a transaction like this expands your atomic batch, right? So it gets bigger, so you can include multiple statements rather than just one. So if anything fails, everything is rolled back to where you started.
Absolutely. This relations thing, we've kind of talked a lot about this. This is, again, there's the real power of a relational database. Clues in the name, guys. That's why it's called a relational database. And because it's so good at representing parent-child relationships, master detail stuff, and maintaining the integrity of that and making sure that you can't mess up.
You can't have projects without owners, for example, or children without parents in that case.
So if you've got these are the kind of things that are very difficult to represent in flat files. So these kind of things. So this is where the power of database happens, where you are linked.
In a flat file, the data just gets so big.
Yeah. I mean, you can
it's all
serialize
denormalized into these strings that are just not half as nice.
No, that's right. So we already called this out when we were looking at the create table statements before. The idea basically is that the child table entities have a column in them in which you store the key value of some parent.
Yes.
And then that allows you to do simple select from project where customer ID equals some value, and you can easily pick out all the child records for that particular customer. So that's kind of the idea, and this is easily done with a create table statement, and we already walked through this before, where you storing in it the customer ID column there is the value of a parent customer record.
Right.
So your project table, of course, and it still contains all of the project items for the whole project, for the whole app, but they are sortable. You can select now based on a customer ID.
That's valuable too, because unlike serializing a collection where you might have all of your records and you could serialize that into a JSON file and just save it to a file, the problem is if you ever want to read that, you have to deserialize all of it, bring all of it into memory, and then select the ones you want. Well, as soon as you have hundreds, thousands, hundreds of thousands of records, that's very unreasonable to be able to do that, your performance-wise. And so a relational database like this doesn't pull everything into memory. It only pulls into memory the pieces that you want, specified by the predicate you create and pass in as your where clause.
Absolutely. So, and I mentioned before this weirdness of SQLite, if you like. SQLite has been around for a long time, and for backwards compatibility, foreign key constraints are actually not. So you can have a foreign key constraint specified. I'll just go back to the previous slide. You see that foreign key customer ID references customer ID at the bottom there? That's a foreign key constraint, which in most databases would be enough to force the database to make sure you cannot put any bad data into this.
Right.
It would maintain that constraint. Not SQLite, weirdly. So just because they wanted to make sure that it would continue to work if people were using older revisions of SQLite.
It's just one of those things developers need to remember.
Yeah. So you need to execute that parameter to actually turn the constraint on. So
foreign keys are off by constraint. What about other constraints like the primary key? Is it on by default?
That's on by
Okay.
Those are on. Yes, those are. These guys are on. So you got a lot of the features that you would expect to have in any kind of database, and you can use these primary key, unique, not null, check constraints in your create table statements if you're using SQLite PCL. Okay. I've just called out in SQLite-net. There's ways of doing these things as well, using primary key attributes, unique attributes, but you can't actually do not null and check constraints in that one. Lots more information at SQLite.org. You can go and read about it there.
Is that still true?
That's still true.
You can't do not null? Is that still true?
In SQLite.net?
Yeah.
That was my fact when I wrote that slide. I'm willing to be corrected if that turns out not to be the case.
Huh.
Yeah. Yeah.
Huh.
Well, there. Jerry's got that look on his face. So he says, I clearly don't believe you,
We
Andy.
used SQLite.net in our previous MVA, and I could just swear we had null.
Well, we might have to come back to you on that point.
Yeah.
Some debate on that one.
Hey, things change.
They do, absolutely. And I love SQLite. I've been working with it for years, and it may be my knowledge on that particular constraint might be out of date. So.
Yeah, well, I mean, it's just a wrapper anyway, what it does and doesn't support.
Indexes,
Yes.
are very important in relational databases. Now, this is the way you can efficiently go and look up in a large collection. You might have thousands of items in a table, and you want to have efficient lookups of it. So on primary key columns, the primary key for an index, you already get it. So doing select from customers where customer ID equals XYZ.
Yes.
You'll get a quick lookup from that. Again, that's a primary feature of a relational database. But remember, with foreign key columns, this customer ID column that's embedded in your project items, there's no key index automatically created on that column. So if you do a search on the project items table and say, okay, get me all the project items for customer ID XYZ.
Yeah.
Said it American that way. Did you notice?
I did. You're going back and forth. That's impressive.
I'm kind of mid-Atlantic. It's terrible. Then it would have to do a full table scan. It will start on the first record and read down the whole lot in order to find out which ones it needed.
Yeah.
Which is clearly not going to be very efficient unless you put an index on that column. And you can do that by executing a statement like this one shown on the slide. Create index. If not exists, you just give it a name on project and then the column in that. So project is the table and then customer ID is the column.
It's worth saying that creating an index and working with them in a database is certainly an art. There's some skill necessary to just understand what an index is, to understand which index you want to create and which columns to include in that index. That's not what we're teaching here, but it's neat to know that SQLite, if you have enough rows to kind of demand it, supports it. So that's really great. It's really great.
A quick word on tools. So these little databases are stuck away in the app data folders. So, what if you want to actually go and drill in and have a look at what's in it?
Yeah, that's right.
There's two elements to that. First of all, you need a tool to be able to read SQLite databases to do a bit of diagnostic work. And there's one from SQLite.org, which is a command line shell.
Oh, lovely.
So if command line is your thing, then this one is for you, SQLite 3. You can go and download that from SQLite.org.
Okay.
Most of us like IDEs, and there are a bunch of them. I've got one screenshot here, but I'm not recommending any particular one. So you can go and find, just do a search on the web, and there are a bunch of SQLite.
Oh, nice. So
a lot of them are free.
Visual experience if you want to.
Exactly. So
that's nice.
Yeah. How do you actually get at the database? Well, that's kind of interesting. So first of all, for apps running on desktop, you can drill down into your My Documents, the hidden folder, app data, local. So if you're a dev, you'll know how to do this, but this is not a folder that your end users can normally see. It's a hidden folder, and you have to drill down into the app data local packages and use the package ID, which is the GUID of your app you'll find near the top of the package app manifest. And you can drill down and you can go and find your SQLite database, and you can pull it out from there and then open it with one of these tools. Now for mobile at the moment, where we are a couple of weeks after build, there isn't a tool that I've been able to find that makes it easy to get at anything stored in that. But there is this tool, wptoolscoplex.com, which works for Windows Phone 8.1. Still, apparently, at this moment in time, works for UWP apps, Windows 10 devices and emulators. But it does have a dependency on the Windows Phone 8.0 SDK. So basically, you have to go and install Visual Studio 2013 Express or something. And I know and this will improve. So I'm just telling you, this is how it is right now.
Right.
I'm sure that tools will be coming down the line where we haven't got this dependency. But that's
really just talking about taking the database file itself, pulling that off of the device so you can look at it and manipulate it. Now, going the other way is interesting,
just let me show you. Just let me show you very quickly that. So.
Okay.
Yeah. So. You can drill down into, you go off into, I closed this, which is a shame, documents, and, oh no, hang on, I need to go into C:.
While you're looking for that, so one thing you might do is create your database and fill it and structure it the way you want with indexes, columns, and tables, and then ship that with your application. So you're not doing everything inside your application to create the database. You're actually shipping an empty database that you can start putting data into.
Yep.
That's one of the uses of the application folder.
That's right.
Just remember to copy it over to a local folder. So
and if you want read-only, that's fine, yeah. So this is where you find the app data local packages, and you can drill down. This isn't necessarily the right one. You go down to local state, and it's nothing in there, but earlier, I went and found the right one for this project, so you kind of have to go off and find the one that matches that.
74C15.
In fact, I could probably go and find that now. I'll go back up to here, and we can just go back to that level and search for that. And there it is. That's actually the app data. So local, is it local state? There we go. There's our database, SQLite PCL demo. So you can just copy it there, or you can open it there. It's
a lot easier if you're building for the desktop, so you don't have to figure out how to get it off the phone.
Paste it up here, and then I can go and open it up here. And now we can drill down into our tables and kind of sort of look at the data.
Nice.
So it's a nice tool for kind of having a good look and see what's going on.
You can build tables with this too, right? You can use your DDLs and...
Yep.
Well, so that's really nice. So I can go through all the hassle, have this tool do all the hard work for me, and then ship a ready-to-go database inside my app.
You can, absolutely.
Yeah, that's nice. That really is nice.
So just to wrap up on this, just a quick word about SQLite is super versatile and very popular, and ends up getting used in a lot of other good tools. So the classical one, if you like, the great exciting one, we've got another session on cloud where we're looking at Azure App Service mobile apps. It used to be called Azure Mobile Services. It's now, there's a new version coming out with more features.
Right.
It's now called Mobile Apps within Azure App Service.
It's probably a company named Mobile Services.
It could well be. And the good thing about that is it's a backend in the cloud, mobile backend in the cloud for your mobile apps. So you can easily share, synchronize data with all your clients. But it includes offline sync.
Yeah.
So you can you can have your application running on your device. It's completely offline, and it's caching all the data, the changes to your data locally. And then when you get a connectivity back, it will synchronize back to the back end. So
and that synchronization gives you concurrency handles as well. So if there happens to be some sort of conflict, you can manage that in your own way.
That's right. And the local storage that it uses on the device, SQLite, and that actually works across iOS and Android. Xamarin and HTML5 web and everything. So it's a super versatile solution. All of them uses, again, this is the power of SQLite. It's available on all of these platforms, and they use it for the local data storage. The other one is Entity Framework 7, which is coming out. There's a great session on build on EF7, which is a lightweight ORM, and that again uses for its backend storage SQLite. But you can use, if Entity Framework is your thing, take a look at that. So
if your question was why a database, it's because a relational database gives you a great way to interact with complicated data. And if you're wondering why SQLite, it's because SQLite is familiar to so many developers and available across so many platforms, and it's capable. It can do what you want it to do with all the tooling and stuff built into the Microsoft tools, as well as open source tooling that you can use to do extra things as well. So I think from that point of view, it's great, right? We can interact with it. We can use SQL statements like we know. We can use transactions like we know and trust. We can create those constraints that we may need as well. It's beautiful.
Yep, it's a lot of fun. Lots of different wrappers. We showed just one. So go and have fun with using SQLite in your apps.
All right, so we're going to take a short break. We'll come back. We'll talk about even more Windows development right here at the Developer's Guide for Windows 10 Insider Preview. We'll see you shortly.
See you soon.